an experiment to interface LED with Raspberry Pi. For this experiment, we need Raspberry Pi 3B plus model we are using, Raspberry Pi board 1. And to interface LED, we need one LED. To interface LED with Raspberry Pi, we need LED. And HDMI to mini HDMI cable we need. And power adapter and display device and keyboard, mouse, jumper wires, and one breadboard for connection. So these are the components required to do this experiment. The circuit diagram is, this is Raspberry Pi model. So the pin, anode pin of LED is connected to pin number 7. In program we have used pin number 7. So you should connect to pin number 7. And cathode is connected to ground. So directly you can connect to ground, or using a resistor, you should connect LED to the ground pin of Raspberry Pi. So how to identify the pin numbers, pin number 7 and ground, I'll show you now. So here, this is Raspberry Pi. The pins which are towards the Raspberry Pi board, they are odd number of pins, and the pins which are outside, so these what I am showing, these pins are even number of pins. Okay, so the same pins configuration I have shown here, and these are odd number of pins. We can count like this: pin number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So this side, all even number of pins comes. How they comes? Pin number 2, 4, 6, 8, 10, 12, 14, 16, 18, and till how much? How many pins? 18, 20, like that, till we get 40 pins. See here, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. So 2 more pins they have to show. So these are the pins on the right side. On the left side, there are odd number of pins like this: 1, 3, 5, 7, 9, 11, 13, and so on. So this is the way of representing the pins. Now I'll explain the program. So this is a Python code written using Python language. The first line is import RPI GPIO as GPIO. This line represents, the RPI stands for Raspberry Pi. Raspberry Pi dot GPIO library, which is a Python module. It allows you to control general purpose input-output pins of Raspberry Pi. Next is import time. This line imports the built-in time module, which provides various time-related functions. So if you want to create a time delay between LED on and LED off, you can use this function. Next line is GPIO set mode GPIO board. So this the meaning of this is, this line sets the numbering mode for GPIO pins to use the physical pin numbers. Just now I explained how to count the physical pin numbers. So the physical pin numbering of Raspberry Pi GPIO. So in this mode, you refer to the pins by their physical numbers on the board. So on board, so if you write GPIO.board, on board, you can use pin numbers. Okay, not GPIO numbers, pin numbers you can use, actual pin numbers. They are called as physical numbers. You have got one more option to write this: GPIO.set mode, GPIO. like this also you can write. That is dot BCM mode. There are two modes to write here. One is board mode, another one is BCM mode. So in board mode, when you set the GPIO mode to board mode, you reference the pins using the physical pins as I told. So the pin numbers as they are labeled on the Raspberry Pi board itself. For example, if you want to control pin number 11, so which is GPIO pin of 17. Here I am using pin number 7. What is the GPIO pin for 7? Let us check it now. I'll show you the pin diagram. In program, I have used pin number 7, the physical pin number 7. So what this side 7 means odd number. So how to count? 1, 3, 5, 7. So this is the green one. This is the pin number 7. But actually it is GPIO 4. So if you are using a board mode, GPIO.board, actually you should write pin number 7. LED is equal to 7. If you are using the program in BCM mode, then you should write this GPIO 4. So you should write it as GPIO 4. You should write 4. That is GPIO 4. If you are using board mode, so then you should write it as pin number 7 directly. So in this way, you can use either the physical pins or the GPIO pins. So if you are using dot BCM mode, you just write 4. 4 indicates GPIO 4. If you are using dot board, you just write 7. 7 indicates the physical pin 7. Both are same. Physical pin number 7 is same as GPIO 4. Okay, so that is about GPIO.board. Next is GPIO set warnings. So GPIO set warnings bracket false. This line disables any warning messages. It will disable the warning messages that our Raspberry Pi GPIO library might generate. If the library file of Raspberry Pi, if it generates some messages, so I don't want to get it on the display. So I want to ignore it. So for that, you have to disable the messages using this statement. GPIO set warning false. If you write to true, you will get the warning messages. If you write false here, you will not get any warning messages. Next is LED is equal to 7. This line defines a variable name LED. Here the variable name is LED. And it assigns the value 7 to it. 7 is the physical pin. So this value represents the physical pin of GPIO pin that you want to use for LED. Next line is GPIO dot setup LED comma GPIO dot out. So this line configures GPIO pin. So which GPIO pin? LED. LED is connected to which pin? Pin number 7. GPIO pin. This line, this line configures GPIO pin specified by the LED variable as output pin. So the pin number 7, you want to make it as output pin. So with the help of this command, you can make that pin as a output pin. So this means you can use it to send the signals to the external devices like an LED. Next is while one loop. So remember, while one, you should put a colon here. This line starts an infinite loop. So we all know that while one is an infinite loop. The code within the loop keep executing repeatedly until the program is stopped manually. So it will keep on executing the program till you stop the program manually. Next is GPIO dot output LED comma 1. This line sets the GPIO pin to high state. So which in turn will turn on the LED. The value 1 represents the high signal. So you are sending 1 to the pin number 7 so that LED is connected to pin number 7, LED becomes on. Time sleep 1. This line introduces a pause of 1 second. 1 means 1 second in the program execution. The program will wait for 1 second before proceeding to the next line of the code. What is the next line of the code? GPIO dot output LED, 0 GPI, that is GPIO dot output LED, 0. So this GPIO dot output LED, 0 will turn off the LED. To turn off the LED, you should send 0 to LED. A value 0 represents a low signal here. The value 1 represents the high signal. Next is time sleep 1. So again, this line introduces another 1 second of pause or a delay. So like this, the loop will be keep on executed till you manually turn off, stop the program. So this is the meaning of a program which after execution of this program, your LED starts blinking for every 1 second.
This is an experiment to interface blinking of LED with Raspberry Pi 3B Plus model, and this is Raspberry Pi 3B Plus model. It has got 4 USB ports. The 2 blue one, there we can connect keyboard and mouse. So you can connect keyboard in the upper port and mouse in the bottom port, or you can exchange anywhere you can connect keyboard and a mouse. And we need one HDMI cable. Micro HDMI cable is connected to HDMI port of Raspberry Pi. Then another end of HDMI cable is connected to the HDMI port of display. This is the display. This is the HDMI port. So the connection is done between display port and the Raspberry Pi. We need one USB cable. Micro USB cable is connected to DC port of display, and the other end of USB cable, it is connected to Raspberry Pi USB port. Okay. We need battery adapter. It is connected to the switchboard, and the other end of the battery, it is connected to the C connector of Raspberry Pi. As soon as we give the power supply, the Raspberry Pi LED turns on. Keyboard is connected to one of the USB port of Raspberry Pi, and same in the similar way, mouse is connected to another USB port of Raspberry Pi. Okay. This is the connection diagram. Now the display is on. Use your mouse, click on terminal, type CD space desktop from the keyboard. So after typing CD space desktop, press enter. So next, you should open your file, you should type nano space name of the program we have given pro1.py. py is the extension for a Python program. Nano space pro1.py, then press enter. So when we press enter, the text editor will open. Here we should type our program. So after typing this program, I have already explained the meaning of program. Now we will execute this program. To save and execute, press Ctrl X, Y. Once again I will tell you, to execute, save and execute this program, Ctrl X and Y and enter. After pressing this, we will get this. Since it is a program for blinking of LED, connect anode of LED and cathode of LED to the breadboard. Anode is connected to pin number 32 of Raspberry Pi. How to count pin number 32?
Indian Apple model.
Sorry, in the program we have used pin number 7, so we should connect anode of LED to pin number 7 of Raspberry Pi. So this side it is odd number pins. The pins which are towards Raspberry Pi, they are odd number of pins, and this side they are even number of pins. So the LED is connected to pin number 7. Now cathode is connected to ground pin. Ground is 14 of Raspberry Pi. This is even side. Count pin number 14 and connect it. To run the program, you should type the command python space name of the program .py. So after press entering, after execution of the program, since the LED is connected to pin number 7 and a ground, so it started blinking. So in this way you can blink your LED using the Raspberry Pi. The whole system is acting as a computer. The display unit, keyboard, mouse, Raspberry Pi, and we are using one breadboard. The entire system, it acts as a computer to blink the LED.